This is JEE 2020 paper 2 section 2, and here there is one or more than one correct options are given there. -2 marking is also there. So let's start our video right after this short break. And if you are first time on my video, then please like, subscribe, and don't forget to hit the bell icon button to get the video first.
Audio Jungle. Audio Jungle.
In this question number 7, a beaker of radius r is filled with water of refractive index 4/3 up to height h. This is the height h is given as shown in the figure on the left. The beaker is kept on a horizontal table rotating with a speed, angular speed omega. Okay, here you can see this second figure. This makes the water surface curved so that the difference in the height of the water level at the center and at the circumference of the beaker is h, and at the circumference of this one h. Okay, means here the aperture created. Okay, and small h is very less than capital H, this one, and small h is very less than also that we say radius. Okay, that is very less as h1 as shown in the figure of the right. Take this surface to be approximately spherical with the curvature of radius r. Which of the following are correct? G is acceleration due to gravity. These options are given. First of all, you have to evaluate capital R, and then what you have to do, you have to find the apparent depth of the bottom to the beaker to the close. These two options, C and D options, are given. So among A, B and C, D, may one only correct. So let's see. To find this capital R, if you go for first A and B option, then you have to find capital R. So capital R is the radius. So that here, what do you find here? Here you have to apply. This one is, let's say this is capital R. And here, as you know, this one is spherical with it's approximately spherical with a radius of curvature capital R. You have to assume over here. So you think about this one. This is one of the surface of a sphere, as this will be the considered as a circle, and somewhere center will be there. So you join over here capital R. So better just, and this is a little small r, and here that is height is capital H, you can say over here. So here you can use Pythagoras theorem. It is very easy. You can find A, B option by the using Pythagoras theorem. So anyone can do this. That doesn't matter. Now come to the point for C and D, apparent depth and real depth. If it is a plane surface, then it is quite easy, mu is equal to real depth or apparent depth. But what about this one? So when the curved surface is there, then you have to go for refractive index formula, that is mu2 by v1 minus mu1 by u, means mu2 by mu1 by v, whatever that is, you say mu1 by mu2, means if it is going from light from dense to rare, then the means formula this is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. So here what you have to do, so refractive index will be considered as water 4/3 and air, that is 1, and then you use this formula as v distance, and v will the distance of the object, and you can go through this. Then it is quite easy. Now let's represent the solution. So for this one, A and B option, A and D options are correct. For A options, you see this is, let's say, be H, and this is capital R. You can see this in diagram, and if you perpendicular drop here, this one is small r radius, so apply here, and this is H. So this is capital R, and capital R minus H, this much is here, this one is R minus H. So use the Pythagoras theorem, and after solving you get R, capital R is equal to H square plus R square upon 2H. Anyhow, A option is correct. Now in the second way, when we see over here the light coming from dense to rare, it will bend, means from dense to rare it will bend this one away from the normal. So this is the normal here, right? So away from the normal when it is going like this way. So mu2 by v1 minus mu1 by u is equal to mu2 minus mu1 upon r. So 1 by v minus 1, this one will be mu2 consider, and this one is mu1 consider, that is 4 by 3 here, and this the height is h and given in the question. So 4 by 3, that is the refractive index, and u will be that is negative of h, means here we have to consider sign convention as also. This is downwards, this is considered to be origin over here. So this one will be minus h, and here then that is plus h. So mu2 minus mu1, that is what we say 1 minus 4 by 3, and then consider h is very less than r. You can assume here this one to be, and solving as we have already evaluated here the value of r also. You see this one capital R, h square plus r square upon 2h you can use over here. So capital R is equal to h square plus r square 2h. This we can use here. So capital R is equal to r square upon 2h. Now come for here 1 by v is equal to 4 by 3. So h minus 2h upon 3 r square, and so h minus h, you just after submitting this value you solve this one and consider h is very less than h. So you can use this one and find minus 4 by 3h 1 plus 3h by 4 2 by 3 h by r square, and after solving you will get this one. So here 1 by v is equal to minus 4 by 3h 1 plus h by r square, but here you see means one of them is, so gh is equal to omega square r square by 2. So r square by h is equal to 2g by omega square you can apply over here and submit, because omega angular velocity is also given. So mod v is equal to 3h by 4 1 plus h omega square by 4g to the power minus 1. So here if you see, then C option is correct. Yes, D option is there. Yes, D option is there, because this is 4g, and C option there is 2g. So D option is correct. In question number 8, a student takes up a ramp that makes an angle 30° with the horizontal. She starts as shown in the figure. At the bottom of the ramp, the speed is v0 and wants to turn around over a semicircular path xyz of radius capital R during the she reaches a maximum height h, small h, at point y, at a point this one y, from the ground as shown in the figure. Assume that the energy loss is negligible and the force is required to for this turn at the highest point provided is her weight only. Okay. So then g is the gravity, acceleration due to gravity in terms of g you have to find. Okay, simply here as here you can see that is the negligible energy means conservation of energy you can apply over here. So simply that is mg sine theta is the force required over here. That is applicable for as mg is downwards, so mg sine theta means theta is there 30° you can say. So mg sine theta or 30° is counter with this. This will be coming from centripetal force. So centripetal force, or in other words, you can say centripetal force is for mg sine theta. Means mg sine theta is providing this centripetal force mv square by r to just move in this curvature. And equate it, you will get the velocity over here. And from energy of conservation also, you can use this among A and B options, and hence as the gravitation force is not providing centripetal force at x and z, by maximum forces applied on x and z for circular motion. So here we can say this one, D option will be correct. The centripetal force required is maximum at points x and z. This one, x and z. So D option will be there from this one among C and D. And anyhow, come to the point. This one for A and B option, apply conservation of energy. So let's start. Applying conservation of energy, half of mv naught square is equal to mgh plus half of mv square. You can see because half of here there is the velocity v naught given in the question. V naught is here. So half mv square is equal to half mv naught square minus mgh on transposing at top point y. Mg sin theta is equal to mv square by r. So mv square by r is equal to mg sin theta. You can equate it. Put this value in equation 1 over here. So you will find v naught square minus 2gh equal to gr by 2. That is option A correct. And for D option, v naught square minus 2gh. This one is the A option. As gravitational force is not providing centripetal force at x and z, that's why maximum force is applied on x and z for circular motion. Come to the question number 9. Again from mechanics, and as from figure it is clear that is a concept of angular momentum somehow. Let's read it. A rod of mass m, this one, and length capital L given, provided at one of its ends, is hanging vertically. Here it's pivoted somehow. A bullet of the same mass moving at speed v strikes the rod at a distance x, from here. It's pivoted and it gets embedded in it. The combined system now rotate with angular velocity, angular speed omega, and the pivot, about the pivot. The maximum angular speed omega m is achieved for x equal to x xm, m suffix. Then you have to find in first two options omega, and then you have to find the maximum x and omega m. So let's represent the solution. What is the strategy over here? So here the strategy means first of all, as here it is hanging a bullet of the same mass as rod moving, this provides this embedded in it. After embedding, what we see here, angular momentum will be conserved. Okay, so mv here, small m is given over here. Here the mass of bullet is given. Yes. So this mv r means the distance from pivot. So mvx equal to, you have to make the this one I omega, means moment of inertia of the system. So for moment of inertia of the system about one end of the rod, that will be ml square by 3. So ml square by 3 you have to apply, and small m is also this one rod, and then this one when m will stick over here, then the distance from axis of rotation, that will be x, so mx square you have to say. So I omega, for I omega moment of inertia, you have to add for rod as well this one bullet. So for bullet, the moment of inertia will be mx square, and the rod, that will be ml square by 3. In this way you will get I omega. So equating, you will find the angular velocity, final angular velocity, you can evaluate it, and then you have to find, as in the option it is given over here. So from this, when you get the omega angular velocity, then you get any one of the option A and B. Now go for C and D options. If you will go for C and D option, then you have to find capital XM and capital omega m. So it means this is here you have to find means maximum angular speed. The maximum angular speed is achieved for x equal to xm. Means here this maximum shows that you have to apply here maxima minima. So for applying maxima minima, you have to differentiate omega in terms of x. If suppose this option is correct or this option is correct, any one option may be. So let me see, whatever there will be the option. So then you have to differentiate this expression of the omega in terms of x. So for the maxima and minima, what the condition for which the maxima minima will be there, that will be the X. So from that you will get this XM, and for this one, for omega m, when you submit this value of XM, then you will get omega m. So now let's represent the solution. So from angular momentum, this was the strategy, and from angular momentum conservation, initial angular momentum and final angular momentum. So mvx is equal to ml square by 3 plus mx square omega. You can find this omega. M is the mass of the bullet and the rod is same. So omega you can find vx upon l square by 3 plus x square. So yes, A option is correct if you see. Now differentiate this for maxima minima. Now for maximum minimum value, d omega by dx equal to 0. So the omega expression was A options was correct. So you can pick the from A option, that was omega. We have evaluated 3vx upon this one l square plus 3x square. So differentiating this, you can use over here by quotient rule either, or simply better just you can use quotient rule, or you can use this one directly as a chain rule also. So this 3v is constant, take outside 3d by dx of x upon l square plus 3x whole square. So here what we have done here, you just you can go ahead for by ddx of 1 by x. 1 by x of differential is negative of 1 by x square. So better just divide this rather than using quotient rule. Better just you divide this with x here over here. So you will get L square by x and 3x square by x. So in this way, L square by x plus 3x by 3x to the whole power minus 1. Now here you can use this chain rule directly, or here directly 1 by x differential negative of 1 by x square and differential of something. So that is a purely mathematical part, and here anyone can do, students of engineering level. So differentiating this one, when we use like this way, if you are not getting able to differentiate directly 1 by x differential, 1 by fx differential means minus 1 by fx square into f dash x, then you can use this one, take this to the power minus 1, and then you can use nx to the power n minus 1 formula and differential of something. So now here purely you can use chain rule. So negative 1 common and this one to the power minus 2, and differential of L square by x plus 3x square. Once again, the differential of 3x will be 3 here, and 1 by x, that is minus 1 by x square. Here you have to apply L square by x square, and then you have to make a 0 for maximum minima. This is the condition, d omega by dx equal to 0. This was the condition for maximum minima. So from here you can get the value of x equal to L by root 3. At this condition, the maxima occur. So it means maximum value of x will be L by root 3. That is also one of the option, and C option is correct from here. When you submit this value x equal to L by root 3 over here in the omega part here, in this one omega part, then what we say here, omega max will be 3v into L by root 3 upon L square plus 3 L square by 3. After solving, you will get root 3v by L 2L. So D option is also correct. So A, C, D. Question number 10 is from modern physics. In an X-ray tube, electrons emitted from a filament carrying current I hit a target anode at a distance d from cathode. The target is kept at a potential V higher than the cathode, resulting in emission of continuous and characteristic X-rays. If the filament current I is decreased to I by 2, the potential difference V is increased to 2V, and the separation distance small d is reduced to d by 2. Then 4 options are given. First of all, if you see the option, then you will find the cutoff wavelength will reduce to half, and the wavelengths of the characteristic X-rays will be remain same. Okay, this is the first option. It means okay. So yes, the cutoff wavelength will be reduced to half, and the wavelengths of the characteristic X-rays will be remain the same. Okay, I'll plot this graph and I'll show you later on. This is may correct. Come to B option, the cutoff wavelength as well wavelength of the characteristic X-ray will remain the same. Okay, so one of the option is correct from A and B. And C, if you see, check the C option, the cutoff voltage will reduce to half with the intensities of the X-ray will decrease. Okay, so this is let's see about this one. D option, the cutoff wavelength will becomes 2 times larger and the intensity of all the X-rays will decrease. Let's represent the solution. Here, if you see this, the graph between intensity and this K, lambda. So here this is the lambda point from where the graph of X-ray is like this way, and this is the Ka point. So energy is hc by lambda, and that is E into V. So that is the V is proportion to 1 by lambda, and that is lambda is proportion to 1 by V. So if V is 2V, then lambda becomes half. So what we see over here in the A option, that was the cutoff wavelength will reduce to half, the wavelengths and characteristic X-ray will remain the same. Okay, and this one in C option, the cutoff wavelength will reduce to half if the intensity of all X-ray will decrease. So A and C option is correct. From here it's obvious. Now check for question number 11. Two identical non-conducting solid spheres of same mass and charge are suspended in air from a common point by two non-conducting massless strings of same length. At the equilibrium, the angle between the string is alpha. The spheres are now immersed in dielectric liquid of density 800 kg per meter cube and dielectric constant 21. If the angle between the strings remains the same after immersion, then first option is the electric forces between the spheres remains unchanged. Electric forces between the spheres reduces, and mass density of the sphere is 840 kg per meter cube. The tension in the strings holding the spheres remains unchanged. So let's go ahead for the solution. Question number 11. Here, if you see, applying this one electrostatic force. So here there are charges Q and this one Q F. So tension, and this one is mg. So you can see over here, let this way alpha. So vertically, semi-vertical angle will be alpha by 2. Here alternate angle alpha by 2. So it's a very common problem over here. So T sine alpha by 2 is equal to equate with this F, and T dash, that what we say in another situation, that is also when it is immersed in liquid, that T dash sine alpha by 2 is equal to F dash. So here you can use this one to different cases. When dielectric constant, when immersed in the liquid, then dielectric constant you have to use this one 21, and here that is, so 1 upon 4 pi epsilon naught cancel, so T upon T dash, that is 21, so T dash equal to T by 21. Now let's T cos alpha by 2 is equal to mg, and T dash cos alpha by 2 is equal to mg minus, here that will be rho Vg also there, that is the thrust force. So thrust is rho Vg, and so mg minus rho Vg, and then equating this, dividing these two equations. So you can find the value of, directly you can find the value of T upon T dash, that is, here there's not dash, T is there, T upon T dash, that is 1 by 20, as we have evaluated over here 21. So 1 by 21 was there, and T dash upon T, okay. 1 minus rho Vg upon dVg. So density of air you can see over here for mg, this one mass means, so 1 by 20, rho by d you have to evaluate, means, so 20 upon 21, 1 minus 1 by 21 by 10, that is of 800, as rho is given 800 over there. So 840 d is kilogram per meter cube. So if you see here 840 kilogram per meter cube, C option is also correct. So A and C options are correct. Question number 12. Starting at point t equal to 0 from the origin with the speed 1 meter per second, a particle follows a two-dimensional trajectory in the xy plane so that its coordinates are related by the equation y equal to x square by 2. Then x and y components of its accelerations are denoted by ax and ay respectively. Then ax equal to 1 meter per second square implies that when the particle is at origin, and these options are given, ax, ay time t equal to 0 and ax equal to 0, what is that? Anyhow, here the equation is y equal to x square by 2. It's a simple question of this one. Although this type of work we won't study in syllabus. So here you can directly you can go for radius of trajectory, or you have to make x and y components and then go ahead like this way. So better just it will be the good approach here directly. That is a equation of trajectory is given. So we will use a radius of trajectory, and later on we will go ahead by simply applying or acceleration ax and ay by using as a considering as a circular trajectory, means that is a is equal to v square by r, like centripetal acceleration. That will be b square by r, and r will be considered as treated as radius of trajectory of this curve. So the formula of radius of trajectory you should know over here, and as radius of trajectory is 1 plus dy by dx whole square to the whole power 3 by 2 upon d square y upon dx square. So you can use this formula directly and you will get the result. So let's see here. If you see, then all four options will be correct. So from at t equal to 0, x equal to 0, here the equation is curve, the pattern of curve is y equal to x square by 2, as x square by 2, so it is bended towards x-axis here. So some bending is there of this concavity. So you see t equal to 0, x equal to 0, u equal to 1 meter per second square. 1 meter per second velocity is there. So y equal to x square by 2, and now what you have to do, differentiate this. After differentiating, you will get vy. So vy will be 2x by 2 vx, and vy, that is 2 cancel, that is x into vx. So ay will be, that is x ax, and then vx square. So what you see here, option A is correct. Yes, option A is correct. That ax equal to 1 implies that when the particle is ay equal to 1. Correct. So option A. If dy by dx equal to x and d square y upon dx square is equal to 1, then applying radius of trajectory here, that is the formula what I told over there, 1 plus dy by dx whole square to the power 3 by 2 upon d square y upon dx square. Submitting the value, you get rc is equal to 1 plus x square to the power 3 by 2 upon 1. At x equal to 0, you will get rc equal to 1, and in this way we get ay equal to v square by rc, that is the centripetal acceleration, you can say. That will be 1. So at x equal to 0, a equal to ay equal to 1. Now B option is also correct, independent of ax. If you see here, ax equal to 0 implies ay equal to 1 at all times. Three options, if you see. If ax is 0, then ay is 0. Yes, ax is 0. And here that is ay is 0 plus vx square. So ay will become 1. And in this way we get option C was there. And vy equal to x vx at x equal to 0. At t equal to 0, by equal to 0, vx equal to 1 meter per second. So D option is also correct.